everyone. In previous lecture we have discussed internal resistance of a cell, potential difference and EM of a cell. In today's lecture we are going to discuss Wheatstone bridge. First of all, we want to know what is meant by bridge. If electrical components are arranged in a form of bridge or ring-like structure, then the electrical circuit is called as bridges. Each bridge can form a loop with 4 arms or branches. Each branches may contain 2 or more electrical components. Bridges are classified into 2 types based on their voltage source. First one DC bridge, second one AC bridge. Next we are going to discuss what is meant by DC bridge. If a bridge circuit can operate only with DC voltage source, then the bridge is said to be DC bridges. DC bridges are used to measure the value of resistance. DC bridges uses comparatively more time to come in balance condition. The circuit diagram of DC bridges are shown below. It is a DC current detector module. Wheatstone bridge, Kelvin bridge are best example for DC bridges. Next we are going to discuss what is meant by AC bridges. If a bridge circuit can operate only with AC voltage source, then it is said to be AC bridges. AC bridges are used to measure the value of inductance, capacitance and frequency. AC bridges takes less time to come in balance condition. The circuit diagram of AC bridges are shown below. It is a current detector module. Hay bridge, Anderson bridge, Maxwell bridge are best example for AC bridges. Next we are going to discuss Introduction to Wheatstone bridge, a English scientist who popularized the Wheatstone bridge. It is a device that accurately measures electrical resistance and widely used in all laboratory. Wheatstone bridge is a diamond-shaped circuit whose concept was developed by Charles Wheatstone, or can be used accurately to measure unknown electrical resistance, or as means of calibrating measuring instrument, voltmeter, ammeter, etc. Wheatstone bridge is also called as resistance bridge to calculate the unknown resistance by balancing 2 legs of a bridge circuit. The Wheatstone bridge comprises of 2 known resistance and 1 unknown resistance and 1 variable resistor which are connected in the form of bridge circuit. Next we are going to discuss working principle of Wheatstone bridge. Wheatstone bridge works on a principle of null deflection, that is, the ratio of resistor are equal, then current flowing through the galvanometer. Under normal condition, the bridge is said to be unbalanced condition, then no current flow through the galvanometer. If the bridge is said to be a balanced condition, then current flowing through the galvanometer is measured. This can be achieved by balancing 2 known resistor PQ and 1 variable resistor S. The Wheatstone bridge can be determined the medium resistor. The working principle of Wheatstone bridge is similar to potentiometer. The Wheatstone bridge is very reliable and it gives accurate measurements. Next we are going to discuss construction of Wheatstone bridge. Wheatstone bridge is a setup to measure an unknown electrical resistance value. Wheatstone bridge has a 4-arm resistor and the ratio of 2 resistors are kept at a fixed value. The unknown resistor is computed by using balance condition or null condition. The source EMF, null detector, galvanometer are connected between the 2 points AC and BD respectively. It is a series parallel combination of 4 resistors that is connected in a bridge circuit and it provides no difference voltage at balance condition. Consider a figure which is shown in slide, which is an arrangement of resistor. This bridge is called as Wheatstone bridge. Wheatstone bridge has a 4-arm resistor in which 2 known resistor and 1 variable resistor and 1 unknown resistor which are connected to source EMF and galvanometer. Wheatstone bridge consists of 4 resistors, namely P, Q, R and S, which is connected with battery EMF E. The EMF supply is attached between the point A and C. The galvanometer is connected between a point B and D respectively. The current flowing through the galvanometer depends upon voltage across it. The bridge is said to be a balanced condition if no current flowing through a coil. The potential difference across the galvanometer is 0. This condition is achieved when potential difference across AB and potential difference across AD will be equal. The potential difference across BC, the potential difference across DC will be remain same. The current enter into the galvanometer is splitted into two, I1, I2, and their magnitude will remain same. The following condition exists when current flowing through the galvanometer is 0, that is I1P is equal to I2R. The bridge is said to be balanced condition. Then the equation can be expressed as I1 is equal to I3 is equal to E by P plus Q. I2 is equal to I4 is equal to E by R plus S, where E is equal to EMF of a battery. By substituting the current equation I1 and I2 in the above equation 1, we get PE divided by P plus Q is equal to RE divided by R plus S. Cancelling EE on right hand side as well as left hand side, we get P divided by P plus Q is equal to R divided by R plus S. Cross multiplying both the sides, we get P into R plus S is equal to R into P plus Q. PR plus PS is equal to RP plus RQ. Cancelling PR on both sides, we get PS is equal to RQ. R is equal to P by Q into S. P by Q is equal to R by S. The equation 2 shows the balance condition of Wheatstone bridge. The value of unknown resistance can be determined with the help of equation 3. Let R be the unknown resistance, S be the standard arm of a bridge, and P and Q be the ratio arm of a bridge. The value of unknown resistance can be determined by using known resistance in a Wheatstone bridge. Next, we are going to discuss error in Wheatstone bridge. The difference between true value and marked value in three resistance which causes error in the instrument. The galvanometer is less sensitive because the accuracy which causes at null point or balancing point. The resistance of a bridge causes because of overheating which generates an error. The thermal EMF causes serious trouble to measure a value of unknown resistance. The personal error can be occurred in a galvanometer to find a reading or by reading the measurement. Next, we are going to discuss sensitivity of Wheatstone bridge. Wheatstone bridge are more sensitive when their resistance are equal and their ratio is equal to unity. The sensitivity decreases when the ratio is less than unity. Reduction in the sensitivity reduces the accuracy of bridge. The sensitivity of Wheatstone bridge is defined as the deflection in the galvanometer per unit current. In unbalanced condition, it causes deflection in the galvanometer. The deflection rate is a function of sensitivity. The total deflection is given by a formula D is equal to S into I, where S is equal to sensitivity, I is equal to current in microampere. Next, we are going to discuss limitation of Wheatstone bridge. For low value of resistance, the resistance of lead and contact become more significant, which introduce an error in a measurement. For a high value of resistance measurement, the measurement is presented by a bridge is so large, the galvanometer is insensitive to imbalance. The other drawback of this galvanometer is to change the resistance due to changes in the value of current flowing through the resistance. The Wheatstone bridge gives an inaccurate reading when it is an unbalanced condition. Wheatstone bridge can measure a resistance value from few ohm to mega ohm. The upper range of Wheatstone bridge will increases with the help of applied EMF. The lower range of Wheatstone bridge can be limited by connecting binding of post. The Wheatstone bridge are very sensitive. The measurement may not be precise in off-load condition. Next, we are going to discuss application of Wheatstone bridge. Wheatstone bridge are used in the precious measurement of low resistance value. Wheatstone bridge along with an operational amplifier are used to measure a physical parameter such as temperature, light and strain. The quantity such as impedance, inductance and capacitance are used to measure variation on the Wheatstone bridge. The Wheatstone Bridge are widely used in the measuring device. The Wheatstone Bridge are used to measure strain and temperature and pressure. The resistance of some material, example semiconductor device, varies with temperature. In an ordinary resistive value is compared with the variation of temperature, then it is called as thermistor. The slight changes in the temperature is measured by using thermistor on the Wheatstone Bridge setup. The Wheatstone Bridge is measured of light by using thermistor. Next we are going to discuss advantage and disadvantages of Wheatstone Bridge. Advantage: it can be easily interfaced with various components. The Wheatstone Bridge is also called as ohm meter. It is used to measure the value of resistance. Disadvantage: the Wheatstone Bridge is not precise and accurate for the measurement of large value of resistance. Wheatstone Bridge for the large value of resistance is in non-linear form. It is a manual detecting. The null detector and galvanometer is required to detect the balance condition. We have come to the end of a section. I hope you all understand today's topic: working principle of Wheatstone Bridge, construction of Wheatstone Bridge, application of Wheatstone Bridge, limitation of Wheatstone Bridge, advantage and disadvantages of Wheatstone Bridge. In the upcoming lecture, we are going to discuss about Metre Bridge. Thank you.